Good evening, everybody. My name is Gata Siliane. I'm going to present about solar radiation, and I'm with Hatimana Kaliste and Gasaro Dolen. And also we have table of contents. For on the first list, there is what is solar radiation. For the second is understanding about solar radiance. How does the sun spectrum relate to solar radiation? And the last one is how does the solar radiation affect the Earth? For starting on this point, we have to ask ourselves all of these questions about solar radiation. First question is, what is the primary source of the solar radiation on the Earth? We have to choose on this list: A, sun; B, moon; C, stars; D, planets. On the second question, there is, which form of electromagnetic waves does the solar radiation primarily consist of? On the A, there is ultraviolet; B, infrared; C, X-rays; D, gamma rays. On the other question, there is, which component of the solar radiation is responsible for photosynthesis in the plant? A, there is ultraviolet radiation, visible light, infrared radiation, and X-ray. This is the questions on the first, so we'll see the solutions on the last point of this topic. So let's continue about the introduction of this topic. Thank you. Let's quickly talk about the introduction. You might ask yourself, what is the solar radiation? Solar radiation is electromagnetic radiation emitted by the sun. It's also energy source of the various processes on the Earth. The amount of the solar radiation reaching a specific location depends on the factors such as the geographic location, time of the day, seasons, local landscape, and weather condition. The angle at which the sun's rays strike the Earth's surface influences the energy received with more direct angles providing higher energy level. So this is the picture which shows solar radiation, how it reaches to the Earth. And also solar radiation is important in production of solar energy, which is a key component of renewable energy sources. Understanding how solar radiation works and its impact on the renewable energy generation is essential. Let's talk about the importance of solar radiation in renewable energy generation. Solar radiation is fundamental to the functioning of solar panels, which are designed to capture solar sunlight and convert it into electricity through photovoltaic cells. You may ask yourselves, what is the importance of solar radiation at all? Here is the solution. There is importance of solar radiation in agriculture. Those are including supporting photosynthesis and crop yield. Second one, influences plant growth and development. Third one, affect nutrient absorption and temperature regulation. Fourth is it helps control pest and disease. And the other point is enhanced drought tolerant. The last one is excessive exposure can have negative effects. Also, there is the topic which calls solar irradiance, and this is the picture which shows solar irradiance. So the solar energy is harmless from the abundant sunlight that reaches the Earth's surface. The measurement and understanding of the solar irradiance, the amount of solar energy received per unit area, and crucial is maximizing the effective and output of the solar energy systems. You may ask yourselves the definition and the measurement on those factors that affecting solar irradiance. First of all, solar irradiance is the power per unit area receiving from the sun in the form of electromagnetic radiation. It's measured using instruments called pyranometer or radiometer, which quantity the amount of solar energy reaching a surface. The unit of the measurement for solar irradiance is watts per square. There is also the factors affecting solar irradiance. On the first list, there is atmospheric condition. Here, atmospheric condition, the Earth's atmosphere affect the amount of the solar radiance reaching to the surface. Factors such as cloud cover, pollution, and atmospheric scattering can reduce solar irradiance.
Hello, ladies and gentlemen. I'm Maximana Calixte. I'm going to proceed where the first presenter stopped. She has been talking about the effects of solar irradiance. So I'm going to start with the time of a day and season. Solar irradiance varies throughout the day and across different seasons due to angle at which sun's rays strike the Earth's surface. Geographical location. The amount of solar irradiance is depends on the latitudes and climate-specific location. Area closer to the equator generally receive high irradiance levels. Solar irradiance and solar energy generation. So also I'm having solar panels. Solar photovoltaic or PV panels convert solar irradiance into electricity. The amount of solar irradiance directly affects the power output of PV panels. So as we know that the area which is near to the equator, they receive higher temperatures compared to the area that live near to the poles. So let me continue with the solar irradiance importance in agriculture, as it directly affects plant growth, crop yield, overall farm productivity. Let's start the point of photosynthesis. Solar irradiance provides the energy needed for photosynthesis, the process by which plants convert sunlight into chemical energy. This energy is essential for plants to produce carbohydrates, which are building body for growth and development. I'm having the second point says crop yield. Solar irradiance influences the rate of photosynthesis, which is turns affect crop yield. Sufficient solar irradiance ensures the optimal plant growth, leading to higher crop productivity. And also we are having plant development. Solar irradiance influences the various aspects of plant development, including stems, elongation, leaf explosion, and flowering. Point 4 says nutrient absorption. Solar irradiance affects the uptake, utilization of nutrients by plants. It stimulates the absorption of essential minerals from the soil, promoting higher plant growth and nutrient-rich crop. And also there is another point says pests and disease control. The solar irradiance can directly contribute to the pest and disease control in agriculture. Sufficient sunlight exposure can help to reduce humidity levels, which can inhibit the growth of certain pests and pathogens. So in the areas which there is high temperatures, there is less the growth of these smaller insects or these pests and diseases, the development. So this can also contribute the reduction of these diseases. So here there is a picture that shows the sun emits EM radiation across the most of electromagnetic spectrum. Although the radiation created in the solar core consists the most X-rays, internal absorption and thermal converts these super high energy photons to lower energy photons before they reach the sun's surface and are emitted out into the space. So here there is a picture that shows the different solar radiation that reaches the surface. So there is the small color that shows the rainbow, which contains different colors like violet, indigos, red, blue. From these colors, this is where the sun's rays comes from, and it contains in these different colors. And also we have seen that these colors, it comes from the sun's radiations or sun's rays. The electromagnetic spectrum have role in agriculture, influencing the various aspects of plants, growth, development, and overall agricultural productivity. Visibility light. Visibility light is essential for photosynthesis, the process by which plants convert light energy into chemical energy to fuel their growth. Different wavelengths which within this range can have specific effects on plants' growth and development, such as promoting flowering or influencing stem elongation. Here is a picture that shows the farm of sunflowers. So it shows that this electromagnetic spectrum it help to this sunflower to in flowering, and also to help it to stem elongation. Infrared IR radiation. IR radiation, especially in the form of far-red light, affects various plant processes. Far-red light is involved in the regulation of seed germination, seedling growth, and the control of flowering. It also influences the shade avoidance response in plants, affecting their morphology and competitive interactions. UV violent UV radiation. UV radiation can have both positive and negative effects on plants. It moderately does. UVB radiation can stimulate the production of natural plants defenses, leading to the stronger, more resistant plants. However, excessive UVB exposure can cause damage to plant tissues, which inhibit photosynthesis and reduce plant yield. Here is a picture that shows different percent of solar radiation. When it is the atmosphere, it is 100%. 50% of direct and diffused radiation absorbed by land and seas. 5% backscattered to space by the atmosphere. 20% reflected from clouds. 20% also radiation absorbed by atmosphere and clouds. 5% reflected on land. 30% lost to space by reflection and scattering. Here also there is the solar radiation is the energy that comes from the sun and is transmitted through space as electromagnetic waves. It has roles in various atmospheric and climatological processes. Solar radiation has significant impact on Earth's climate and various processes. Ways in which solar radiation affects our planet. Heating the Earth's surface. Solar radiation from the sun reaches the Earth's surface, providing energy that warms the planet. The essential energy for maintaining the Earth's average surface temperature, making it habitat to life as well we know it. Driving the water cycle. The solar radiation is important in water cycle. It evaporates water from oceans, lakes, and the other water bodies, forming clouds. These clouds then release precipitation in the form of rain, snow, or dew, which sustain the fresh water sources and support the plant of growth. Influencing climate. Solar radiation in primary drive of Earth's climate. Changes in the amount of solar energy reaches the Earth's atmosphere can influence temperatures and weather system and long-term climate trends. There is also supporting photosynthesis. Solar radiation is essential for photosynthesis, the process by which plants convert sunlight into energy. Plants use solar energy to produce food, release oxygen, and support the entire food chain on Earth. Here also there is the trees that shows how it gets the sun rays from atmosphere, and this sunrise uses it to make their own food. And these plants also have the importance to the human beings, which providing the food for human beings, and also it provides the oxygen which used in the respiration. And also these plants reduces carbon dioxide from atmosphere, which is very important to the human beings and also in the globe at all. Here we are having elements influencing solar radiation. Number of variables can affect the strength and availability of solar radiation, or the energy that sun emits in the form of electromagnetic waves. For solar energy system, the variable is essential to maximizing the effectiveness and effective for solar energy production. The many variables influencing solar radiation as follows. You're having clouds cover, aerosols. Let's talk about two aerosols. The amount of sunlight that reaches the Earth is influenced by particles suspended in the atmosphere, such as dust, pollutants, and volcanic ash. These pollutants or dust, when reaches the atmosphere, can hinder or reduce the amount of energy, which is the amount of energy, sunlight energy reaches to the Earth's surfaces. Let's talk to cloud covers. The major factor limiting the quantity of solar energy that reaches the Earth's surface is cloud's ability to scatter or block sunlight. The cloud sky can reduce the amount of solar insolation. As we know, in different factors, the cloud cover limit or reduce the sun rays that reaches the surface.
Hello guys, hope everyone here is doing amazing. I'm doing Gasser. I'm a student at University of Rwanda College of Agriculture and Animal Science at Busogo campus. So, as my colleague have said, we have given task of discussing or presenting about solar radiation. So, for me, I'm going to talk about solar radiation's place in Earth's energy balance. So, as our planet's main energy source, solar radiation is the main essential to maintaining the energy balance of the world. So, the heat produced by sun's absorption powers number of earthly functioning, including the water cycle, ocean currents, and atmospheric circulation. So here we have synopsis of solar energy technologies. So technology related to solar energy include the range of technical for using sunshine to produce heat or electricity. So through the process of photovoltaic effect, photovoltaic cells, sometimes referred to as solar cells, directly convert sunlight into electricity. So usually composed of silicon or other semiconducting materials, these cells collect photons from sunlight and produce an electricity current as a result. So, a current of electricity is produced when sunlight strikes the solar cells, exciting the material's electrons. So let's talk about solar radiation applications. So in solar radiation application, we have residential and commercial solar power system. So using this system, photovoltaic or PV system to generate energy is one of the most popular uses for solar radiation. And this system uses solar panels which can be placed on rooftops or in open areas to turn sunlight into electricity. We also have solar thermal system for heating and cooling. So these systems use solar radiation to heat and cool buildings. Water is heated using solar heating devices using sunshine. We also have solar radiation significances or importance to energy planning and management. So forecasting solar radiation is important for energy management and planning, particularly when the solar energy is being generated to maximize solar power systems dependability and efficiency. Precise solar radiation forecasting, it is very crucial. So the influence of solar radiation uh, the influence of solar radiation forecast on energy production is major advantage. Solar panels' ability to generate electricity is closely correlated with the amount of sunshine they receive. And also, operators can anticipate variation in energy outputs and modify their operations accordingly by precisely forecasting solar radiation level. This proactive methodology. So, and also, what are the research on solar radiation's future direction? So, future development in solar radiation studies will be influenced by both the growing needs for sustainable energy source and the ongoing progress in technology. Key development and innovation in solar energy research, including tandem solar cells, as I have said, is an effort to increase efficiency and lower cost. Tandem solar cells, which combines multiple layers of various materials to capture a large spectrum of sunlight, are the subject of intensive research. So here are some questions someone can ask he or herself. We have the first questions about solar radiation. It's multiple choice. What is the primary source of solar radiation on Earth? A. Moon. B. A. Sun. B. Moon. C. Stars. D. Planets. So the answer is Sun, as you see. The second question is, which form of electromagnetic waves does the solar radiation primarily consist of? A. Ultraviolet. B. Infrared. C. X-rays. D. Gamma rays. So the answer is A. Ultraviolet. And also, what is the total solar energy reaching the Earth's surface approximately? 100 watt, 500, 1000 watt, 500 watt, 2000 watt, 1361 watt. So the answer is D. So the next question you have, what happens to the solar radiation that is not absorbed or scattered by the atmosphere and reaches the ground directly? It forms shadows. B. It causes rainbows. C. It creates auroras. D. It generates heat. So the answer is A. It forms shadows. The last question we have, which component of solar radiation is responsible for photosynthesis in plants? A. Ultraviolet radiation. B. Visible light. C. Infrared radiation. D. X-rays. So the answer is B, which is visible light. So here is some references where we got this presentation or our work. If you are not satisfied, you can better visit these references. Thank you for watching. If there is any question or suggestion, let me say in comment section. Thank you.